Okay, so welcome to the data access. Get started with the RSP session, hosted by myself, Gloria Fonseca Alvarez, and Yumi Choi. Yep, okay. Some reminders, we do have a code of conduct, very important as we saw today. And also a reminder to please respect people's comfort levels, both with COVID and also social interactions. Reminder, we have a Zoom. I'm currently sharing via Zoom, and we have a channel for the session. So if you have questions, if you're on Zoom, you can put them on in the Slack channel. Or if you maybe are a bit shy, you can also do that. But yeah, keep yourself muted if you're on Zoom. And then, so what we'll cover today, some essential concepts like how to get help, who is there to help you, what are the policy for data rights, how to set up an RSP account. We can help you set one up right now if you need, and also some basics about the Rubin Science Platform aspects, and also we'll try to do some live demos. And then lastly, we'll hear from Frosty about the RSP roadmap. Okay. So you might have seen some of these faces before. The Rubin Community Science team, we're here to help you. I'm Gloria, I'm in the Community Science team. But if you see us walking around and you have any questions, please feel free to come up to us and ask. Or if you don't have the chance to talk to us during the meeting, you can get help via the Rubin Community Forum at community.lsst.org. We have a support category where you can you have a guaranteed answer from Rubin staff, and you can also chat with other science community members. There's also a users committee whose job is soliciting feedback from the community and communicating that to the Rubin operations director. The names of those people are the user committee, and we're also, I believe, currently looking for new members. The Rubin data policy, scientists, which includes students, working or are enrolled in a US or Chilean institution have automatic data rights, but there are also several members of international teams that have data rights via in-kind contributions. There's also a proprietary period, but the alerts are immediately public. So as you might have heard, there's going to be a lot of data from the LSST, and you won't be able to download all of this data, right? So the Rubin Science Platform is a set of web-based applications and tools that will allow you to not only access the data, but analyze the data in an environment that is next to the data. There are some key services and tools that we usually just say via their acronyms, so I'm just going to define them. Table Access Protocol, so TAP. It's a IVOA standard service that enables queries of catalog data. So this is how you will likely be querying the DP2 data sets. There's also the Butler, which is a middleware that manages reads and writes data sets. So Butler kind of, I think of it as like it goes and retrieves your data, right? There's also Firefly, which is an interactive interface that enables exploration of image and table data. You might see it later for image interaction. There's also simple image access, SIA, which provides a standardized model for accessing image metadata. And there's also server-side operations for data access SODA. This you might see in the context of image cutouts. All of the Rubin Science Platform documentation lives at rsp.lsst.io. There you can see how to get an account. There's user guides for all the different aspects of the RSP. There's how to get support, and you can get updates as well. Now we'll go over and talk about how to get an RSP account. So if you already know that you have data rights, if you're in a US or Chilean institution, or if you know that you're part of an in-kind team, but you don't have an account already, you can go to ls.st/RSP signup. And you can access your account via different ways, like your institutional credentials, GitHub, org ID. But if you want to follow along in this session or later, please go to that and we'll help you during, and you might get approved during the session. We do recommend that you link a second identity provider. Like, for example, if you're a student and you're going to move institutions soon, do get a second, for example, GitHub or Work ID. I use GitHub. And then you'll still be able to access your account even if you move institutions. So if you do get approved for your account, what do you get? Well, you get access to the data previews via the portal, notebook, and API aspects. There's no currently there's no alternative way of accessing this data, so you do need the Rubin Science Platform. You do get some personal storage, 40 gigs, and then some computing power of 4 CPU and 32 gigs of RAM. And we'll hear about the roadmap at the end of the session. You do have the ability of having groups. So these are user-managed groups where you can have, for example, your research group, or if you're hosting a workshop, you can create a group and share, share code, share like specific files with like data IDs and stuff like that. But this is just the instructions on how to create a group. You have to go to id.lsst.cloud login, and if you, am I moving? It'll look something like this, like that, where there's a bunch of groups already that some of them you can join, they're open or they're closed. But you can, if you go to my groups, you'll be able to create your own groups. Okay, next I'm gonna talk about the specific RSP aspects. And if to actually access the Rubin Science Platform, go to data.lsst.cloud and you can log in, and you'll see that there's different ways of interacting with the data. There's the portal where you can easily discover data. There's the notebooks, which is a Jupyter Lab interface. And then there's APIs, which allow you to access data remotely. I'm going to talk about the API first. So API, I think, stands for Automatic Programming Interface. Yeah, I said it earlier this morning, but I forgot. Okay, so API. So what are some things that you might want to use an API for? One, accessing Rubin data from outside of the Rubin Science Platform, or you might want to integrate data access into your own software tool. So this would be really important if you're developing a tool that uses Rubin data, right? And you can also use it to access external data sets. But for each one of the aspects, there is a guide. And this is just showing you here the guide for the API aspect. And we also have tutorials for each one of the different aspects. I'm just showing a screenshot of the data preview 1 page. For the API tutorial, since we're still building the tutorials, but we do have a lot already for the DP1. So if you wanted to try them for the DP2, you can follow along with those. We do have some tutorials already on dp2.lsst.io. Now, if you are super familiar with API and you just want to know how to actually get to Rubin data, you can go to the authentication instructions at rsp.lsst.io/guide/authorization. And this is for the TAP endpoints. But you can use APIs with TAP, SIA, SOTA cutouts, and you can also explore HIPS maps. So this is just showing an example of how it would look to access Rubin catalog data using this is for TopCat. But you can also access images via simple image access, and you can display them with DS9 or Aladdin. So there's the portal aspect user guide. So the portal aspect is an interactive interface where you can explore data. So there's no programming required. It has services in IVOA standards like Table access protocol, TAP, which I mentioned, simple image access. Yeah. And you can use the portal to browse data sets, view the schema, and I'll show you more specifically what that means. And you can find and retrieve and display data. So this is really useful if you don't have programming experience and you just want to get started, like maybe you're a student just getting started, or if you just want a quick look at the data, a quick look at the catalogs, or retrieve an image, and I'm going to show you how to retrieve an image. We do have, like I said, an extensive number of tutorials for the DP1 for the portal. The DP2 tutorials are coming soon, but you can find the DP1 at dp1.lsft.io. So once you get to the portal, you can access all of the currently available catalogs. You see here that there's a tab that has both Data Preview 1 and Data Preview 2 catalogs. And you can enter your constraints. Maybe you're interested in a particular coordinate. And you can see all of the different tables that we have available. The object table for source table, the AA object tables, and also like the solar system catalogs. And you see here that you can also interact with, you can look for hip maps, which are really pretty, and I will show you one, show you later. But you can also query for images. Also, you can query images via SIA, and you can also retrieve specific alerts. So I mentioned the schema. So that just tells you basically the columns and their descriptions for the different catalogs. So if you want, we do have like a schema page, but if you wanted to, if you're already in the portal and you want to know what's in this table, you can quickly see all of the different columns and their descriptions. You can query for data. So you can do that in two ways. We have a user interface assisted where you just click around. So there's a table on the right that shows you for whatever table you've already selected, what the different columns are, and you can just click the specific columns that you want. You can do spatial constraints, and you can also put constraints on the individual columns. But you can also use something called the astronomical data query language. ADQL is similar to SQL if you've worked with that before. But you can also just put in a query directly if you don't want to click around. So this is what the results page looks like. You see there's usually 3 different panels. On the left, those usually, like if you query for image, your image will be there. This is the HIPS map. There'll be a table, and you can also create plots and interact with them. You can also query for images. So now that we have 2 of the data previews, you can specifically select to only query for images in the DP2. And there's also for the SIA access for both the DP2 and the DP1. Now, if you look for images, it might look something like this. But this is specifically from the DP0, but it should look something like that for the DP1 and the DP2. Now, I'm going to actually go to the portal and try to show you how to browse the HIPS maps and how to access an image. Now I'm going to copy these. So who wants to log in but has not logged into the Rubin Science Platform? So I can wait. No. Okay. All right, I'll just show you that. Okay. So in the slides, I've already conveniently added a link to the HIPS map. That goes. Okay. It's asking me to sign in again. Okay, I have failed at clicking the link. So I'm just going to show you how to get to it. So if you click on portal, there is a Rubin HIPS search, but you can also, if it's not there, it should also be available via this little like hamburger menu where you can find hip snaps. Okay, Rubin hip search. And there's a few different available. There's in all of the 6 different LCST bands, but I'm gonna look at the DP2 GRI Pretty Coad, and I have some specific. Yep.
Thing on a computer.
Yes.
And you're going kind of fast.
Okay.
Will there be an opportunity for us to sit down with some of you and get set up on this? Because I am stuck on some sort of circle of hell here trying to log in. I have no idea what's going on. We don't have to do this now, but is there some sit down time where you can work with people? Melissa. Hey, Melissa.
Sorry. Either you can type into the Slack channel and tell me what the issues are, or come and sit down
Okay,
here.
I just didn't know for new users if there was designated time.
So yeah, for people who are having access issues, right now we're just using Slack, and I'm checking.
Oh, people are having access issues. Excellent.
All the time. Yeah, they
Oh,
forget.
okay,
People forget how to log in.
It's not just me. Okay.
Yeah,
good.
yeah. So
Okay.
try in the Slack. We'll try to work it out and get you online.
Thank you.
Or-
All right,
yeah.
fine.
Okay. And let me start over, since I did go pretty fast. Okay. So if you go to data.lsst.cloud, I'm not sure. Okay. So that is the address for the Rubin Science Platform. I'm already signed in, so I definitely skipped a bunch of steps. But if you are not signed in and you have been approved already, I'll wait a couple of minutes so that you can sign in, so that you can follow along. But if you click on each one of these things, it'll take you to a different way of interacting with the data. I was clicking the portal, and the portal is great because you can quickly look at the data, but it's also not great in that I click on stuff too fast and then you can't follow along. But okay. So hopefully some of you have been able to log in, and then you click on the portal, and this is where it lands. There's different tabs that allow you to look for different data products and also different data releases. There's a HIP search. So HIPs, unfortunately, I don't know what that stands for, but it allows you to look at I'll just show you, but it's just a map of the sky in a colorful way that allows you to see where have we observed in this particular data release, right? There's the images where you can put some coordinates. You can tell it where, like what kind of image you want. There's catalogs. There's a bunch of different tables that you can access, and you can also access different collections, like you have DP1 data, DP2 data. We also have DP0.2 data, but yeah. Then you can also access images via simple image access. And I mentioned before, super briefly, you can access alerts with the alert viewer. You can also upload your own tables to do cross-matching. And I was just gonna show you a HIPS map. But I said before, there are HIPS maps for all of the different bands, UG, R, IC, and Y. But there's also the pretty coads, and that's the one I was gonna show you. You can put in some coordinates. I'm gonna put in the coordinates that I had before. Then I'm gonna go back to my presentation and grab again. Okay. So these are the coordinates of M49. M49. And some people have questions? Yes. Okay.
I'm where you are, but you have more tabs across the top, and one I'm missing is the HIP search.
Okay, yeah. So if you don't have that, I think that appears because I have interacted with the HIPS search before, but if you don't see one of these things, you can go to the little hamburger menu on the top left, and it should be there. It has the Rubin hip search. If you don't see the SIA thing, it's there as well. So if you click on that, you'll get to the same spot. Yeah. Okay. All right. And then can you see the coordinates? I just put in 2 coordinates. You don't have to, but I just put in the coordinates, and then I'm going to click search. And if you zoom out, I'm just zooming out with my trackpad. But as you zoom out, it updates. But now it's a beautiful galaxy. So you might recognize this from, I think, first look images. But if you zoom out more and more, you'll be able to see more of what was covered. This is specifically for what was covered for the DP2 release, early DP2 release. Okay, so if you zoom out, you'll see there's a sphere, and you might recognize this little stripe from all of the times that we've shown the DP2 sky map. But you can just, I'm just clicking on it and dragging my trackpad. And you can just see the coverage that we have with the DP2. And you can zoom in other parts of it as well. But yeah, so this is a great way to interact with the data to see what was covered. Is my favorite, part of the sky in this data release. Then next up, I wanted to show you how to access images. So right, you'll see that once you click the search, it goes to the results page. You can go back if you want to do a different search. You just click on the tab again, right? So if you wanted to search for a different part of the HIPS map, you can just put in you can click on HIPS search again and put new coordinates. But what I'm going to do now is try to find an image. Okay. So the tab leads you to looking for images using something called ops tab. Tab again is table access protocol. And so you should have these things here. So you can select what kind of image you want. You can select a location in the sky. Maybe for the DP2, there's the coads, but there's no visit images. But for example, if you wanted to in the future look for a specific visit, you could put in your the specific date. You can also select bands, or if you have a specific object, you can also look for it via its object ID. But all I'm going to do is try to find, so for that location that I put in before, I just want to see what kind of coads exist for that in the DP2. So the Rubin images have different calibration levels. The deep coads are calibration level 3, and so you click here, Rubin coads and difference images. And then you also want to select that you only want to get data from the DP2. So under collections, lsst.dp2. And then you'll see that for calibration level 3, that also involves difference images. So we don't want to get that right now. So you do want to select a subtype of data product. So for that, it would be lsst.deepcoads. Okay. And then for the location, I'm going to just put in the coordinates that I had before. And then I'm going to just click search. Okay. And so if you want to actually look at the images, there's like different tabs here. There's the coverage, which also shows you the HIPS map already. Then you have your data products, which is what your image will appear. Okay, so this is a deep coad at the location of that of M49. You'll see that there's several results. There's 4 results here, one in the U band, one in the G band, and one in the R band. So you can click through the different images to see what those look like. And you'll see also there's a chart area, but since this is an image, this is not a very useful chart initially. But you can also look at the at all of the images together. Okay, and you can also one of the quick things that you can do is you can, if you click on this little target-looking thing, you can enter your position, and I'm just going to copy paste the coordinates that I had before, and you can mark where that is in the image. So you see here, that what we were looking at, that beautiful image that we had before, that's where this is at in the deep coads. Yeah, I think that is all I wanted to show for the portal. And if I don't answer your questions right now, please feel free to come and like ask me and during the breaks or something. But yeah, I'll take questions now. Awesome. Love to hear that.
Thanks. So if you're using things like the tap interface, is it possible to save queries to come back to later, or do you always have to keep them externally and then cut and paste them into the interfaces?
I am not sure if that's available right now. Somebody answer.
Yeah, in the portal, you'll see a tab called Job Monitor, and in that you'll see a history of the queries that you've performed. And when you go to a query in the Job Monitor, there's a little info button, an I in a circle, a letter I in a circle, and you click on that, and you'll see the actual ADQL that was issued.
Okay, can you hear me okay in the back of the room? How about now? Is it better? Okay, good. My name is Yumi Choi. I am also a CST member. And Gloria just went through all the basics of the RSP and the, how to get an account and the API and the portal aspect of it. But now I'm gonna talk about the notebook aspect of the RSP. So notebook aspects allows you to do more complicated science analysis using like Jupyter notebooks and the Python scripts. So if you are already using either Jupyter notebooks or Pythons for your science, you're very much ready to use it. But one missing piece is to learn how to access to the data and retrieve the data, Rubin data products. And once you retrieve the data, you want to analyze and then save them in a format that you want to, then from there you can just do analysis like you usually do. And the notebook aspect is like your mini computers in the cloud. So you have your own work environment there. So you don't need to download your data. So you just log into the RSP and then start the notebook aspect, and then you can configure your work environment. So in the rsp.lsst.io documentation page, there is a how-to guide for configuring your work environment. So for example, you can configure your GitHub repo access from your RSP account, and also you can configure your share environment. And then if you don't see the packages you want to use, you can install them in your working environment too. And as Gloria mentioned, if you have collaborators who have the data rights and then also RSP accounts, then you can create a group for your collaboration to share files and the code. So you can manage, create and manage your group. All right, and then please remind that the RSP is the shared resources across the entire Rubin community. So always try to save some resources. So you can do that by save and shut down all the notebooks and then log out from your work sessions once you're done with your work session. Okay. And then, so once you click the notebook aspect from the RSP main page, this is the landing page you will see. And then the welcome page will appear like this. And then this work environment has like pre-installed LSST science pipelines, and as well as a lot of like commonly used Python packages. So in many cases, you don't need to install like common packages like, NumPy, AstroPy, or things like that. So those are pretty much pre-installed for you. And then for each user have 40 gigabytes of storage and 4 CPU and 32 gigabytes of memory. So this is the current number. But if you have something bigger than that and temporary products from your analysis, and then you don't need to keep them forever for your within your 40 gigabytes of storage, then you can use Scratch space. So there is a Scratch directory you can use, so you can save temporary things there. But then that Scratch directory is deleted every Sunday, so please keep that in mind. All right. Okay, so this might look like your typical notebook aspect working screen. So in one side, you probably open a notebook, Jupyter notebook you're working on, and then you access to the data you want and retrieve them and save them and analyze them and then make some plots. So you have notebooks on one side, but also you can use the Firefly viewer visualization tools in the notebook aspect as well. So you can trigger, launch the Fireflies from the notebook aspect. So maybe this is a useful and efficient way for your data analysis. So you don't need to go back and forth between the portal aspect to use the Firefly and the notebooks for the notebook aspect. So you can open them side by side and then just to explore. Right. And if you're not a big fan of doing doing your science in Jupyter Notebook, then you can, of course, from the Python scripts and then command line things in the terminal. So there is an option for you. And if you're not used to using Jupyter Notebooks or Python at all for your science, then don't worry about it. We have plenty of the tutorials, notebook tutorials that you can reference. So while this is not the Python tutorials, but it has a lot of pieces, so you can probably pick it over time. So that means you don't need to start from the scratch. There's a lot of tutorials you can reference. So if you go to the RSP and then select the notebook aspect, under the tutorials tab, do you see that? Okay, so we provide tutorials in 3 different levels. The 100 level tutorials are for the how-to things. So for example, how to use Jupyter Lab, or how to use Butler, or how to use Tab, or how to display images with Firefly and things like that. And the 200 level tutorials are for data products. So we have many different types of data products from each release, and 200 level tutorials have demonstrations for each of the data products we release, and what are the, how to access those particular data products, and what are the use cases for those data products, and then what are the key columns for the tables or what are the extensions of the image data. So that kind of basic information about all the data products are available in the 200 level tutorials. And then 300 level tutorials are more for the science demo. So we assume a simple science analysis case. So each tutorial has like, okay, I want to measure this, or I want to do this. Then we start from retrieving the relevant data sets and then do some analysis and then get the final result. So 300 level tutorials demonstrate like science cases, and we are trying to cover broad topics as much as possible from our community science team expertise, but it doesn't cover everything, of course, but there's good amount of tutorials you can use. And maybe if you select one tutorial, then if you open that tutorial before, you might see the warnings like, do you want to overwrite? That means that if you open this tutorial, they will be saved in the notebooks/tutorial directory, which is under your home directory. So it's just about your files, what you did before on the same tutorial you're about to open. So don't worry about it. It doesn't affect any other tutorials. So you can save or overwrite whatever you want to do. Okay, so we've been through all the slides about the notebook aspects. Before we're doing some demos, does anyone have questions or troubles to get into those tutorials?
Hi, just two simple questions. I hope they're simple. Question one, there are 4 CPUs when you come in. How big are those CPUs? I mean, are there zillions of ZPUs, or is it like a laptop CPU, like a quad 4 computer thing? It doesn't really matter, but I was just curious.
Maybe Frosty, do you have an answer? 1 second. Okay. Do you have another question?
Yes.
Yeah.
The second question is, in terms of saving resources, it's very reasonable to shut things down after a few days and things like that. But if we accidentally leave it open for 6 days and we had meant to log out and then forgot, can we get back anything of it back, or is it really gone forever?
So I think the RSP will shut down your kernels if you're not coming back like after many days.
Right.
So there's automatically shut down your kernels and everything. But it's like after 6 days or 7 days, something like that.
Yeah.
So yeah.
There you go.
Okay, so I did realize I posted a very long thing this morning, but there is useful information in it that nobody has had a chance to read yet. So we look at your usage and do trade-offs to try and figure out where we should be spending our resources. So one of the things that we realized is that you guys were running out of memory a lot, but a lot of your containers were generally idle, which is fine. It's an interactive thing. You do a thing and then you go to dinner. So what we've done is we have traded memory for lifetime. So right now you get 32 gigs of memory, up from the 16 that you were having around the time of DP1. But in exchange, now we shut containers after 5 days. This is not 5 days of idle time. This is max lifetime. Also, remember that while our reliability is actually quite satisfactory, even to some perfectionists like me, we do occasionally terminate sessions on Thursday afternoons during the updates. It's quite rare, but it does happen. So all this is to say, instead of trying to keep track of it, basically, if you have code that does long-running computations that is running, and try to structure it in such a way that you're dumping out intermediate results all the time, so that if you have to come back and your session is interrupted, you don't lose like 5 days of work. And if you're interactively working, save often. In the future, there will be a version that actually auto-saves, so I won't have to badger you about saving often. But definitely in terms of long computations, try to break them up in shorter computations and flush to storage your results. And I think that's the best thing to do. I just don't be super like concerned about the resource saving at this point because we do actually, it turns out that CPU is not the dominant resource consumption in the system. It's actually storage. So I'm hoping that we can actually increase the computing capability without breaking the bank soon. One of the trades that we made in order to get early DP2 out is we have hosted the deep coads on cloud, and so that increased Bob's bill. Bob's no longer here. That's fine. So yeah, we do these trade-offs all the time, and you can also like give us feedback. And I think once we get to steady state, we'll start polling as well directly users through the community to go, would you like more of this or more of that? But yeah, so yeah, save your work often if you run into the notebook, and don't rely on the uptime. Although, like I said, the uptime is right now a maximum of 5 days. And actually, are you in a browser? Excellent. Can you go to the homepage? Data is still cloud. And no, actually, like not your notebook, the actual homepage. Yeah. And if you go to your username, brand new feature. Sorry, we haven't had a chance to show it off to much yet. You go to quotas. So under your settings page, you will now actually see all currently applied quotas on the platform, which is useful because we, instead of putting them in documentation, we didn't want to do that because we do actually adjust them up and down depending on what's happening. And if a particular user is like, has some code that's going berserk, we can actually also adjust that user. So this page, the number, you can trust those numbers. Those numbers are generated. I know it doesn't look like a dashboard, but it is essentially a dashboard. So this actually shows you all the limits, and then it needs a little bit of sorry that kind of dumped in fairly raw fashion. Will improve the phrasing in the future. And then there are some limits that are just like, I think the most interesting one is the concurrent queries limit. So a lot of I don't mean to take over the session. A lot of web services just do API limits, like GitHub logs you out if you do too many requests. But typical like requests are very cheap. And so the only thing they care about is how many you make. With us, we have the opposite problem. Actually, you doing lots of small, efficient queries is actually a lot better for us than you doing one really long query. So we don't want to stop you doing lots of small queries. We actually want to stop you doing lots of long queries. I mean, not stop you, but make you think about it. And so there is now a limit that is a concurrency limit, which means that if you have 12 queries running already because they're really long running queries, you can't submit a 13th one until one of them finishes. And again, this is like a level of finessing that we didn't have for DP1. We're adding those things all the time. Most of those limits are picked, so 99% of users will never notice they're there. We like literally look at the usage and then just cut off at the very top. So hopefully they're not very inconvenient, but they do help, and we'll keep fine tuning them.
Okay, thank you, Frosty. So let's go back to the notebook aspect. And this is a landing page, and then you can see this tutorials tab. So if you want to follow along with the hot off the press data and the tutorials, you go there and then look at the DP2, and under 100 level, go to the 101 series and click the 101-3. So data services and overview. So I thought it would be safe if I do just with the rendered HTML version of this thing instead of doing the live demo. So if you want to follow along, open that particular notebook from the RSP. So this is pretty, it's particularly good one because it shows the all kinds of like data access services available for the Rubin data access in the RSP. So basically, the bottler, which is the middleware between the pipelines and the data products. The bottler is one way, and then tap service is another way, and CS service is another thing we could use, and then cutout services. So in this tutorial, we're demonstrating how to access catalog data and how to access image data in different methods. So at the beginning, we just instantiate all the services we're going to use. So this RSP discovery, instantiate RSP discovery with the DP2 release first. So this RSP discovery is the class that provides you like discovery of the services within the RSP, and then create the authenticated client services for you. So using that, we first instantiate the tap service. So discovery.get tap client, so that you're setting with the tap service. And then also discovery.get SIA client, which instantiate the SIA service for you. And then we also instantiate the butlers. All right, so for this tutorial, we just define the target array and deck coordinates and then searching radius we're going to use for all the different queries. So first, catalog data. So catalog data is accessible via either tap or the butler service, but the recommended way is using the tap service. So to use the tap service, you first start with the ADQL query, which is the astronomical data query language, which is very similar to SQL if you're familiar with that. So in the ADQL query, you select the columns from which table, identify which table. So in this case, from the DP2 object table, and then where clause provide the spatial constraints. So, around this target coordinates with this searching radius. So all the sources that are within that searching circle, I want to retrieve these columns from this table. And also you can add like constraints on the columns in the table. So here, as an example, we put magnitude limits, like something brighter than 17th magnitude, both in G and R, but fainter than 23rd magnitude in both filter. So once we have this ADQL query written, then we submit that query as an asynchronous job. This is important. So you submit job as a background job. So server is doing the jobs for you, but you can continue working on your laptop, Jupyter notebooks for the cells that doesn't require the retrieved result. So you can just do other analysis and cell executions while the query is running from the server side for you. Then once the query is done, you just fetch the result and save them as a table format, like the AstroPy table or Pandas data frame, whatever familiar with you. And then the butler is also could be used for the catalog data, but there is a limitation because with the butler, tables are returned for the entire tract or entire visit. So, and then you cannot apply any constraints on spatial coordinates or the columns. So this is really limited compared to tap query, right? So unless you need all the sources within particular visits or particular tract, Butler is not way to access to the catalog data, but tab is the way, right? But it's possible. And then for the image data, which is the pixel data, you can access via Butler, SIA, tab, and the cutout services. So this is all the ways you can get the pixel data from the RSP. So among those 4 options, Butler is the recommended way to get the image because it requires the least amount of information from you. So you just provide what kind of, sky area you're interested in to get the images and what kind of filters you want. Maybe that's the minimum information you need to provide. So you just ask Butler to get the queries. I want the deep coed around this part of the sky in R band. So this is the Butler query, and then it returns the metadata information about the images overlapping in that part of the sky. So then you can just ask Butler to get that image. So you just pass the image metadata information to the Butler, and then it gives you the image. So that's easy. But if you use the SIA service to get the image data as well, but that requires extra steps, which is you have to like identify this sky of interest. That's easy, but you have to tell what is the calibration level. So as Gloria shown in the portal service, in the IVOA standard, the deep coed is on level 3 calibration, and then you get the image metadata by using that. But then from using that metadata information, you need to retrieve the image URL, like the URL where you can actually retrieve that particular image you're looking for. So this is an extra steps. So then you have to pass this URL information to the SIA service to let it retrieve the image for you. Right, so tag is also possible. It's the same, almost same with the SIA service, which requires extra steps to get the image URL. But with tab, you are getting the image metadata from the OPSCore tables. So that's why tab service also available for the image data. So for this one, you have to write ADQL query to use the tab service. So here you're saying like, okay, I want to use from the IVOA OPSCore table, I want to the image metadata information for the part of the sky in the R band deep coed images. So they return image metadata information, and then using that, you also have to get the image URL, and then you can retrieve the images from there. Right. The last thing is cutouts. You probably have many science cases you need or you want to look at the little stems of your target of interest, right? So in this example, you have like central coordinates for your cutouts and then the size of your cutouts. And then that's used for the defining the searching circle. And you are now using the SIA service. This is just an example you can do using the tab service. But to figure out, identify which is the from which large image you want to make the cutout. So first, you need to know a larger image provided by from the Rubin data products, right? And then you from that larger image you want to make a cutout. So figure out that large image first. So retrieve the image data for that large image, and then you establish the like remote image cutout service session for you, and then get the URL for the session service sessions. And then you have to pass all the image ID from which we're gonna make cutouts, and then pass how what kind of cutouts around what kind of coordinates you wanna make. So that way you can access to the pixel data. So this is all data access services available at Rubin. So this particular notebook tutorial is a great place to start. So I pause here and take any questions.
Thank you. This is awesome. I have a silly question, a slightly more complicated question. The silly question is, do you guys refer to it as Butler or the Butler?
Butler. Butler.
Just Butler. Okay. Okay. All right. The second, yes, we of an older generation remember the search engine Ask Jeeves. So he'd be like Jeeves, right?
Jeeves.
Because he was a butler. But the more interesting question, I think, is that you have all these techniques of getting images, right? There's the SIA, there's the tap, there's the butler. Are each one of them sufficiently unique that we should know them all, or is it okay just to learn like one and then do other tasks with just the one task that we've learned? I'm thinking specifically about my undergraduate students who would like to learn exactly one
For us,
way.
There is no one true way. So the answer is actually situational. It depends on what you're actually trying to do. So with a lot of this tooling, and obviously this is early days, and I accept that we haven't necessarily had the time to like really explain the kind of power tricks with some of these things. But with more tooling, there's basically always a trade-off of simplicity versus power. So there's two ways to think about it. Either you find the most complicated way because it will always be fine. That's great if you have the brain capacity for it. I'm more on the use as little as you need in order to do the job, right? So for example, SIA is literally in the name, simple image search. If you can do what you need to do with SIA, I would say use SIA. Now, if you need to go there and examine the four-dimensional, provenance properties of a Butler data frame, use the Butler. I don't even know whether what I just said makes sense, but it sounded good. But I think there is a I would say use the simplest tool for the job. And an example of this, for example, is in the cutout service that Ian was talking about. You can also get kind of like small PNG type image, or you can get a full cutout of the data set. Again, what to do? Well, use a simple one if the simple one will do. You're just looking at morphology, or use the full one if you need something else. So that's one of the reasons. There's many ways. The second reason is the HexKCD joke. If you have 10 standards, the only kind of outcome is to think about it very hard and then exit the room with 11 standards. There are multiple standards for some of those things, and we try to be standards compliant because of clients that people use. So there is a little bit of that. But anyway, I would say keep it simple if you can.
Thank you. Sounds like I should just teach them SIA for now. Okay, thanks.
Yep, thanks. So there is a tutorials for the simple image cutouts and bulk image cutouts. So I think maybe if I add something, let's say you have one big tract you're interested in, you want to make multiple cutouts from one single big tract image. Then maybe using the Butler, retrieve the data and then define the pixel corners you want to make a cutouts. That might be an easier way. But if you have like multiple small cutouts distributed across the entire sky, then maybe using the SIA service or TAP service might be an easy way to do that, right? So whatever easier for you is the way, I think. All right, so the next tutorial, I'm not going to go over the entire tutorial, just want to point out the best practices for TAP queries. So this is 102-1. So in the section 4 of this tutorial, it shows each cases, but again, the RSP is the shared resources. So, and then for you, making your query as efficient is important, right? You want your query run quickly, then take longer, right? And that also help others too. So the number one is use asynchronous queries. So you submit your queries as a background job. So let it run it for you on the server side, and then you can do other stuff and then come back later to check your query results. And then number two is specify the columns to be returned. So it's tempting to do like select all from a table, right? But then some tables have a lot of columns, like more than 1,000 columns, and you don't want to retrieve all of them. So just maybe from the portals, you can figure out which columns are useful for your science cases and predefine, and then try to retrieve all those columns. Then number 3 is use spatial constraints on sky coordinates if possible. So unless you're looking like blindly searching anything from the whole sky, you might have, in many cases, you might have the, spatial constraints. You are interested in parts of the sky, right? Not entire sky, some cases. So in that case, this is because, our Rubin catalog are partitioned based on their sky coordinates. So by providing the spatial constraints, it really reduced number of chunks of the files the server has to scan through. So that's really recommended. And also number 4 is the apply column constraints when it's possible. So in addition to the spatial constraints, adding some column constraints might help. Right. And then the last tutorial I want to touch a little bit. Oh, I want to erase this one. Okay. And this one, 102-5. So this is the tutorial that shows the cross-match to uploaded table with tab. So in many cases, we have you have your own catalogs from other surveys or from literature, and you now want to compare against the Rubin catalogs to see what are the Rubin measurements for those particular objects, right? So to do that, we have provide the functionality that users can upload their catalog to the server temporarily, and then use them for the cross-matching against the Rubin catalogs. So this is an example table we created from the Swan Sky Survey catalog, and then we want to do cross-match against the DP2 object table. So we want to select some columns from a user table, but also some columns from the DP2 object table. But we want to join those two tables spatially, right? So for example, using the cross-matching radius of 1 arcsecond. So in that case, to make your cross-match query efficient, you have to use join on distance statement. So this distance function, once it passes to the QServ, its ADQL interpreter from the QServ side interpret this as like, okay, there is a user uploaded table. So we now partition user table in the exact same way we did for the Rubin catalogs, and then only comparing the chunk that are overlapping in spatially. So using this join on distance, using this, you don't need the server doesn't blindly scan all the chunk of the Rubin catalog. So it only look at the overlapping region and then make your query super efficient. So use this function for your user uploaded cross match. Yep. Oh, can you wait for the mic?
So where would you upload your table?
So your home directory, and then just have the right path for you. So you can upload your table to your home directory, whatever, you can create your own directories under wherever, right? So this is for the tutorial repos, so you cannot use this. But yeah, I can upload my own table to my own account space and then using that. Yeah. Or if the other surveys provide the API thing, then you can access from the Rubin Science Platform to that server, for example, Gaia. So we have that example in this tutorial. So for example, we set up the Gaia tab URL, and then inside RSP, we access to the Gaia server, and then retrieve some solar system objects. And then they have like MPC designation, which the columns we also have in our Rubin catalog. So you retrieve the Gaia data from inside RSP, and then save the results as a table, and then upload the table to our QServe, and then ask to cross-match with our solar system object table based on the this MPC designation. So that's another way you could use. You don't need to save your table and then upload to your work session in that case, right? If you have access to other servers from the RSP, if that's possible. Right. Any other questions? Oh, you have. Oh. Ah, so what I would do, like I have my own work directory, and then you can just select your file and then drag. Maybe I should.
I think she wants to know how you.
I just. Yeah, sorry. Yeah, that's right. So that's what I'm gonna try, like, I don't know, just like this. Drag and, drag and drop works. Yep. Yep. Okay, so if there's no more question, I think I want to hand it over to Frosty to talk about RSP roadmap.
This one's charged. Okay. Right. So hello. We shipped DP2 4 hours ago. We've just returned our 300th millionth row of catalog results. So you guys are slamming us. No, stop. No, okay. But anyway, that actually is relevant because I just want to say that we did not plan for so many releases, right? Like the plan was to do DR1, and now we've done DP 0.1, 0.2, 0.3, DP2, DP0, DP1, DP2 early, full DP2 is coming, APDB is coming, full DP2 is coming, and processing is coming. So these are all releases that we weren't like geared up to do so many releases. I was saying to Bob, our director, that by the time we get to DR1, we'll have done more than the 10 data releases we're supposed to do in our entire lifetime. And this is all a way of saying is that we are spending a lot of time trying to improve our release machinery because we seem to be doing so many of them. And also to make sure that the system stays performant for you guys as we're adding more and more data. So that basically takes effort away from actually the things that I would prefer to be doing, which is adding more features to the platform. So kind of an expectation management. So going through the down the hill towards Christmas, you're going to get more data, but you're probably not going to get more features. I think is the kind of summary of that. That is, if it actually if there's significant features, we do always monitor our ability to give you like quick wins. I'm not going to tell you what it is because it's going to make me sad, but I did actually pull a feature that was going to be released because it just wasn't working well enough. But if there is something small to do, we will do it. But in general, we're just putting all our effort into reliability, uptime, performance, and shipping more data. If we can stop shipping new data long enough to actually do some more feature development, I just want to say that next year we do have a whole bunch of things planned. There's a lot of interest in integrating AI capabilities in the platform. We know that there's a lot of interest in more collaborative features, like, for example, you and your student being able to work on the same notebook at once, all that kind of thing. And also we know that there's, we've always planned, I know there's a lot of interest in basically higher throughput computing in the science platform, like more cores for a brief amount of time, parallelization, all that kind of stuff. So there's a very long development roadmap for the next few years. It's just that right now it's going to be just more data. So that's basically it. Does anybody have any questions? Okay. Good night. I'll see you tomorrow.
Thank you. This is the last slides. So there are some sessions that are related to data products. So if you want to learn more about the data products details, on Tuesday, status and performance of alerts and prompt products and the solar system prompts processing results and pipeline sessions are planned. And on Wednesday, get started with EDP2 session. I think Jeff is chairing the session. It's more focused on the EDP2. And on Thursday, there is a validating DP2 data products for science analysis. So those are the sessions you might want to also check it out. Right. Thanks, everyone. And always post your questions in the community forum if you need any help. Thank you.